interactive web map used to examine the various attributes of cities in order to explore the concept of the rhythm or pulse, a concept which many argue is unique to each city. An introduction to CityPulse is followed by a review of relevant literature used in the project, a demonstration of the CityPulse application, and a review of conclusions reached during the project's development. CityPulse was inspired by an October 2010 episode of the radio program called Radiolab. The episode, entitled Cities, presented several different stories, with the aim of trying to determine, in the words of the show's producers, what makes cities tick. One segment of the Cities episode introduced the work of Dr. Robert Levine, professor of psychology at the California State University at Fresno. In 1997, he published a book, A Geography of Time, in which he measured over a year several distinct attributes in a set of 36 U.S. cities. The examination of these attributes serves as an integral part of the CityPulse application. The subsequent segment in the program introduced the work of Drs. Louis Betancourt and Jeffrey West, theoretical physicists from the Santa Fe Institute in New Mexico. Building upon the work of Dr. Levine, the physicists used and expanded the set of U.S. cities while demonstrating the application of theories they have used in particle physics. Here we see the scanned image of a table included in Dr. Levine's book, Geography of Time. Included in the table are the 36 cities in which Dr. Levine performed measurements. Those measurements included a number of variables related to temporal phenomena and population size. CityPulse examines 5 of these measurements: population, talking speed, walking speed, banking speed, and coronary heart disease, which is calculated as a mortality rate for the disease. Drs. Betancourt and West build upon Dr. Levine's earlier work and introduce their application of universal scaling laws they have applied in their own work in particle physics. A brief example of the law's calculation is shown here. Further, Drs. Betancourt and West argue that the pulse of a city, in other words, how best to characterize and rank a city, can be measured using one variable, namely population size. By applying the universal scaling laws to the population variable, the physicists argue for the use of a new metric for ranking cities. Such a metric, they claim, can be used to determine how well a city is performing or underperforming. For example, what is the city's GDP, or how many patents are they producing annually? In the Cities episode, Drs. Betancourt and West claim that their scaling laws are 80 to 100% accurate in predicting the expected values of variables like those just mentioned. As already discussed, the motivation for CityPulse was a Radiolab episode in which the hosts Jonah Lehrer and Jada Bumrad interview both Dr. Levine as well as Dr. Betancourt and Dr. West. Dr. Levine's work is outlined in his book, A Geography of Time. Additionally, Betancourt and West's scaling laws and their application in measuring a city's pulse are introduced in the article, Urban Scaling and Its Deviations, Revealing the Structure of Wealth, Innovation, and Crime Across Cities, an article produced by the physicists for the Public Library of Science, a peer-reviewed open-access online resource. CityPulse draws on existing studies in geovisualization and the tools used in exploratory analysis. Earlier work in geovisualization by Alan MacEachren and David DiBiase outlined 3 stages of scientific inquiry and insight generation, namely exploration, confirmation, and presentation. It is in this first stage, that of exploration and hypothesis formation, that CityPulse operates. Additional studies done by Natalia and Gennady Andrienko, Patrick Lundblad, Terry Slocum, and Mark Hauer were used as additional sources in geovisualization work. Their studies helped to narrow down the choice of tools that CityPulse would need for presenting and exploring the data from the perspective datasets of Betancourt and West and Levine. Dr. Betancourt and West have already produced a simple web mashup wherein they have mapped their data. This mashup, however, offers very limited interaction. Also, trends over time are difficult to detect using this simple tool. CityPulse is an advancement in interactive techniques as well as data exploration. CityPulse is a Google mashup utilizing the Google Maps API. The tools employed by CityPulse are unique to each dataset. An example is shown here, namely the parallel coordinate plot used in the Levine dataset. The Google map employed by CityPulse uses circular color points in the map in order to identify individual cities. Additional tools afford the ability of panning, zooming, and adjusting the base map appearance. The data selection panel includes drop-down menus used to select which data set the user wishes to explore, as well as the attributes specific to each data set. Temporal controls below the drop-down menus are used for animation of the Betancourt and West data, as will be shown in the demonstration. About, Reset, and Help buttons are included as well. For the Levine perspective, lines in the parallel coordinate plot demonstrate how individual cities trend across the selected attributes, while proportional symbols are used to show the magnitude for each attribute in these respective cities. Selection is a linked action between both the PCP lines and the points on the map. For the Betancourt and West perspective, a bivariate map is employed to compare cities based on population and a selected variable. Colors are used to show the city's average performance above or below their expected performance as determined using the physicist's universal scaling laws. Because this perspective uses a larger number of cities, proportional symbols were not used for the city points, which instead are all equal sized. As with the PCP and the Levine data, here there is linked selection between the bivariate map and the Google map. This is CityPulse. As discussed previously, CityPulse is a geovisualization tool spawned from the NPR program Radiolab that aims to create insight into the pulse of cities. To progress to the actual application, simply click the View Map button in the lower right corner. After the loading, the user is presented with a set of visualization tools, and the data of Dr. Robert Levine is loaded. The map is the central feature and primary visualization tool for the application. The data from both perspectives stretches across the U.S., so the map is initially centered over the United States. Each city is represented by a discrete point on the map. When viewing the Levine data, these points are scaled in proportion to the value of the attribute being examined. A legend to determine the value corresponding with the size is shown here in the upper left. We will discuss the points for the Betancourt and West data later. By selecting any point on the map, you can examine the attributes associated with that city. Simply click the X in the upper corner to dismiss this message box. Thanks to the manipulation tools provided by Google, it is also possible to zoom in on an area and explore in greater detail. But first, let's make some room. This base map has all the basic features you would find in the regular Google Maps service. You've already seen its ability to zoom in and out, but it can also pan and change the style of the base map. To get back to the original state, you can use the built-in zoom controls, or by using the data selection panel. This is the data selection panel, one of 3 such panels in the display. This panel, as with all panels, can be maximized or minimized by clicking the name on the tab. Inside the panel is a set of menus, animation controls, and buttons that allow the user to interact with the data. The topmost drop-down menu selects which data set you're viewing. Below that are the attribute and temporal selection menus. These allow you to change which attribute is being compared, such as talking, walking and banking speeds, and what year the data is for. Below these are the animation controls. These controls are designed to be used with the data of Betancourt and West, which has an inherent temporal component, and are not functional when the Levine data is being examined. The buttons at the bottom of the panel are self-explanatory. The About button gives information on the attributes, while the Help button gives information on the tools and how to use them. Right now we're going to click the Reset button. As you can see, the Reset button brings you back to where you started with the map. More specifically, the Reset button recenters the map over the U.S., sets the selected attribute back to the default for each data set, and maximizes all tools associated with that data. So far, we've looked at the basic tool to view the data in a spatial way. Let's move on to the exploratory tools in CityPulse. For the Levine dataset, we use a parallel coordinate plot, or PCP, to show how each city trends across the available attributes. In the PCP, each axis represents an attribute that can be examined, and the point where each city crosses an axis represents the value of that attribute within the city. Trends are found in this plot when lines either follow each other, a direct relationship, or cross each other, an inverse relationship. Lines can be selected by rolling over them with the cursor. When a line is highlighted in the PCP, the corresponding point is also selected on the map. This also works in reverse order. Selecting the point on the map highlights the line in the PCP. Now let's move on to the Betancourt and West data and the tools for that. Again, we change data sets using the data selection panel. The theory used by Betancourt and West is based on the idea that population determines the characteristics of a geographic area. The data used to confirm this theory compares the actual gross domestic product of a city to the theorized value that the area should produce, creating a percent deviation from the expectation. Percent deviation and gross domestic product are plotted in a bivariate map, which replaces the PCP used for Levine. This bivariate map plots cities based on two factors, the first being population, and the second being either percent deviation or GDP as selected by the user. This method allows the user to see a direct correlation between the theory of Betancourt and West and the real-world phenomena. As in the PCP, you can mouse over a point and highlight it in the bivariate map and on the base map, or vice versa. The Betancourt and West dataset also has a temporal component. The Betancourt and West data also has a temporal component, allowing the user the use of animation to show trends over time. Using the controls in the dataset selection panel, an animation can be played in a continuous loop or step forward or backward through time. By using animation in coordination with the bivariate map, temporal patterns can be noticed in the data. Clusters that form or disperse in the data become visible, and the change in the general shape of the data becomes evident. To try the CityPulse application, please visit the website posted here. CityPulse has proven to be a useful geo-visualization tool. Visualization of the Levine dataset gives a tangible understanding of the comparison between cities. Using the proportional symbols, it is easy to see clusters and trends in the data, such as the high walking speed prevalent in California. Combining the bivariate map and animation on the Betancourt and West data has also proven useful in showing how cities trend over time. As time progresses, cities as a whole seem to cluster in small groups and move closer to the expected value of GDP when comparing the percent deviation attribute. CityPulse has vast potential for future expansion. Expanding the filtering techniques to enable the user to select a range of cities based on attributes, or enabling the map itself to automatically filter visible cities based on zoom level, would greatly increase the ability of the application as an analytical tool. Along those same lines, selection of clusters of cities in both the bivariate map and the base map would enable the user to see how clusters of cities in certain geographic areas compare, or how cities with similar attribute characteristics are spread spatially. Integrating each data set so that it can make full use of both analytical tools would also increase the utility of the application. This functionality will be largely determined by the ability to effectively filter data in a way that disappearance becomes a non-issue. Documentation and help in the current implementation are adequate but allow for improvement. Adding help and documentation for individual tools would enable more efficient and effective problem solving and debugging tools for the user. The improvements just mentioned remain project aims with future development of CityPulse.